Hello students, in this video I will be explaining exercises concerning scatter plots. The scatter plot below shows the number of moose M estimated to be living in the Minnesota from 2005 to 2012. Which of the following equations best models the population of moose in Minnesota during this time period, where T represents the years since 2005? Now, looking at the scatter plot, we could obviously draw a line that is between those values. It goes like this, for example. Okay, so this line approximates the scatter plot. Now, remember that a straight line has the form of y equals ax plus b, where a is the slope and b is the intercept. Looking at the line here, the intercept should be positive, since this is the value of my intercept. Accordingly, the choices are all possible concerning the intercept. Whereas, my slope should be negative since my line is decreasing. Thus, those two choices should be rejected for now. Now, going further, if you look at the intercept is close to 8,000. Thus, my answer should be choice A and not choice B, since my intercept is really far from 10,343. And accordingly, my answer is choice A. Going further to question number 2. During the 2014-2015 season, a statistician collected data on a professional sports team. The scatter plot below shows his findings for the average minutes played per game and the average points scored per game for each player on the team. Which of the following equations best relates minutes played per game x and points scored per game p for players on this team? If we look at this scatter plot, its best fit would look something like this, which is an increasing line. Thus my slope should be positive, which is okay for all of those. Now my intercept would be negative since this is 0 and my intercept is at this point. Accordingly, it can't be choice D nor choice B. Now let's calculate the slope of this line. So let's take any 2 points on this line. You could choose, for example, this point here, which is at x equals to 12 and y equals to 4. Let's choose another point, for example, this point here, which is at x equals to 18 and y equals to 7. So 18 and 7. So my slope should be y2 minus y1 over x2 minus x1, which is equal to 7 minus 4 divided by 18 minus 12, which is equal to 3 over 6, which is approximately equal to 0.5. Thus, my answer is choice C and not choice A. Question number 3 now. The scatter plot drawn below depicts the percentage of Maryland residents born in Maryland, Y, between the years 19,000 and 2000. If X represents the number of years since 19,000, which of the following equations best describes the relationship shown? So now, looking at the scatter plot, if you want to draw a best fit, it would look something like this, or let me fix it. It's approximately something like this, which is a decreasing line. Thus my slope should be negative. My intercept should be positive. So accordingly, this is a good case. This is not so good, since neither the slope is negative nor the intercept is positive. Here the intercept is negative, thus it's not the case. And now this is probably a good case. Let's look at our cases now. Take any 2 points on this straight line. Let's take this one, for example, which is the point that's 35 and 70. So 35, 70. Take another point, for example, this point, which is at 60 and 60 at the same time. So the point 60, 60. Now just do the values, which are y2 minus y1 over x2 minus x1. You will get the slope, or something near to the slope, which is 60 minus 70 divided by 60 minus 35, which is equal to minus 10 divided by 25. That's approximately minus 0.4. So this value is closer to minus 0.3 than to minus 3.3. Thus I would reject choice D and take choice A. Going to question number 4, the scatter plot below shows the number of college students N in millions who enrolled in at least one online course from 2002 to 2011, where T represents years since 2002. A best fit line that approximates the data is also shown on the scatter plot. Which of the following is closest to the yearly increase in online college student enrollment from 2002 to 2011? Now, looking at the scatter plot and the best fit, we could take 2 points. For example, let's take this point, which is at x equals to 2, y equals to 2.5. Let's take another point which is at 5.5, for example, here, and y equals to 4.5. We have those 2 points are on our best fit line. In order to calculate the yearly increase, we need to calculate the slope, which is 4.5 million, since the data is in million. So let's write m and we'll convert later on, minus 2.5 million, so that's y2 minus y1, over x2 minus x1, which are the values of, so that's x2 minus x1, which are the values of 5.5 minus 2, and this would give me 2 million divided by 3.5, which is approximately equal to 0.571 million. Multiplying this by the million, what's a million? 1 million is 10 to the 6. Accordingly, multiply this value by 10 to the power of 6, you will get something that's close to 571,000. So this value is closest to the choice number B, and thus our answer is choice number B. Last but not least, question number 5. Matthews calculated his car's average fuel economy Y in miles per gallon for various speeds X in miles per hour, and recorded his data along with a best fit curve on the scatter plot to the right. Based on the model, which of the following is true? So now let's look at this scatter plot. And we have the best fit, which looks like a parabola that is concave down. If we look at choice number A, they are saying Matthew's car gets a maximum fuel economy of approximately 46 miles per gallon. The maximum is always at the vertex. So the maximum value at this vertex is not 46, it's roughly 33, for example. So accordingly, choice number A is wrong. Choice number B, Matthew's car obtains its maximum fuel economy when traveling approximately 46 miles per hour. So at a speed of 46 miles per hour, do I get my maximum value? Actually, yes. If you look here at the vertex, it has an x value which is equal to 46 miles per hour. Thus, this is a correct statement. Looking at choice number C, the car's fuel economy increased by approximately 46 miles per gallon as it increases its rate from 0 miles per hour to 70 miles per hour. Is that true? So going from 0 to 70 miles per hour, do I increase by 46 miles per gallon? Here we don't have constant increase, so we can't calculate the slope of the straight line since this curve, this best fit, is not a straight line. Thus, this statement is wrong. Last but not least, looking at choice number D, Matthew's car has a fuel economy of approximately 46 miles per gallon, regardless of the speed. Now looking at the curve, the speed while changing changes the miles per gallon. Accordingly, we don't have a fixed miles per gallon no matter what the value of the speed is. Thus, choice number D is also wrong, and my only correct choice would be choice number B. Thank you for watching this session.